In this video, we'll be using Ketchup's law to find the currents I1, I2, I3, and I4. So the first thing we're going to do is we're going to assign polarities to the resistors that have no polarities yet. So we're going to do that with respect to the 10 volts power source. So this will be plus, minus, plus, minus, plus, minus, plus, minus. Next thing we do is we assign our currents to the branches that have no currents yet. So we call this branch current I5. Then we can call this branch current I6. We can then proceed to write the KCL and KVL equations that we use to analyze the circuit. So first off, let's write the KCL equation at this node, and that would be, so let's call this node 1, and we'll call this node 2. Call this one node 3. So write KCL at node 1. And that would be it at I1 as current entering the node, plus I5 minus I2 equals 0. This infers that I1, let's say I2 minus I1 equals I5. Let's call this our first equation. Then we can come to node 2, say KCL at node 2. We can say that current entering the node I4 minus I5 minus I3 equals 0. We can therefore say that I4 minus I3 equals I5. We can also write at node 3 KCL at node 3 as I6 equals, so you say I6 minus I1 minus I4 equals 0. That is I6 equals I1 minus I1 plus I4. We call this the third equation. Second equation. We can also identify 3 loops here. This is loop 1, loop 2, and loop 3. And we can then proceed to write the KVL in loop 1, loop 2, and loop 3. So the KVL in loop 1, we have 2I1, 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 then plus 8I2 minus 10 equals 0. Then we can say that 2i1 plus 8i2 equals 10. Let's call this our fourth equation. We can then proceed to the second loop. So starting from here, we have plus 5, that's KVL loop 2. So we have 5, then plus 6i3, 6i3, then minus 8i2, minus 8i2 equals 0. So we can basically say that 8i2 minus 6i3 equals 5. Call this our fifth equation. We can then proceed to write the KVL for loop 3. So KVL loop 3 would be so we'll start from here. That would be 4i4 minus 5 minus 2i1 equals 0. This infers that 4i4 minus 2i1 equals 5. Call this our sixth equation. If you go back to equations 1 and 2, we can basically equate them into one another. Since the two of them are equals to i5, you can say that i2 minus i1 equals i4 minus i3. So we can just say that i2 minus i1 plus i3 equals i4. We will call this our seventh equation. We can substitute it into equation 6. Then we would have that 4 open bracket i2 minus i1 plus i3 minus 2i1 equals 5. This would be our eighth equation, which could be simplified further into 4i2 minus 4i1 plus 4i3 minus 2i1 equals 5. Then we have 4i2 minus 6i1 plus 4i3 equals 5. We call this one our eighth equation. So we can solve it simultaneously with our eighth equation simultaneously with the fifth equation and the fourth equation, and that would give us later we get that I1 equals 0.4 amperes, I2 equals 1.15 amperes, I3 equals 0.7 amperes, and I4 equals 1.45 amperes. Thank you for watching. If you found this video helpful, please like, share and subscribe. Later.